Kia ora, Year 12 and 13. This is a video looking at how we find the square roots of a complex number. I'm going to do two examples in this video. I'm going to do one pretty slowly and then the second one really fast. I want you to use pen and paper and try and work through it with me as we go. So the first one that we're going to do is to find the square roots, which I suppose I'd better write out nicely. Find the square roots of, and let's do 21 minus 20i. Now, if you're being observant, you will notice that I've said in the question roots, not root. When we talk about the square root of a real number, such as 36, we learn in about year 10 or 11 or 12 that we define the square root of that to be 6. In other words, it's the positive value that when I times it by itself will give me 36. We don't seem to do that with square roots of complex numbers, so we're going to get two square roots for this one here. One will be positive and one will be the negative times negative 1 of that. And we get it by thinking about, well, what does it mean for something to be a square root? So I want the thing times the thing is going to give me 21 minus 20i. So we're going to let z equal x plus iy. And we're going to say, well, what values of x and y will work to give me 21 minus 20i. And we want the coefficients here to be real numbers, okay, so that it looks like an ordinary old complex number like we've seen for the last couple of days. So we're going to substitute that in and off we go. We're going to do the obvious thing on this side, which is to expand. So we'll get x squared plus 2xyi plus I squared y squared is equal to 21 minus 20i. To have two complex numbers be equal, we need the real part to be equal and the imaginary part to be equal. So here, my real part is x squared minus y squared, just working with that I squared, plus 2xyi is equal to 21 minus 20i. So we're now going to equate this with 21 and this, the 2xy, with negative 20. I suggest that you pause now and try and get as far through as you can without me and then keep on watching to check. I'll do the next part on a new slide. Okay, so we've got x squared minus y squared equals 21 and we've got 2xy is equal to negative 20. We need to find, to get this into an equation of one variable, so we're going to use this to eliminate y from that first equation. Y is equal to negative 10 over x. So now we take this and we substitute it back in here. We have x squared minus negative 10 on x squared is equal to 21. X squared minus 100 over x squared is 21. Now getting a common denominator of x squared, I'm going to end up with x to the power of 4 minus 100 equals 21x squared. I've just multiplied everything through by x squared. Hopefully you're recognizing this now as a disguised quadratic. So don't freak out when you see the x to the power of 4. They're actually pretty straightforward if we recognize the pattern. So for most of you watching, you probably will be able to see that and go straight to factorizing, going x squared something, x squared plus something, x squared minus something. Well, we want minus 21 here and minus 100, so it'll be minus 25 here and plus 4. If you are struggling with that, remember that the other way we can go here is to say let u equals x squared, and then we'll have u squared minus 21u minus 100 equals 0, and we can go and solve that for u and then work back to get x squared. Okay, ask me if you want some help doing it that way, but I think this should be fine. Now, what do I have to do now? Well, I have to say when is this 0 or when is this 0? So that's coming on the next slide. So we've got x squared plus 4. I'll just write that line out again, because it's pretty important. We're getting quite close to the solution now. So x squared plus 4 equals 0 has no real solutions. So we can ditch that because we need our x to be real. Here we get two solutions. X is equal to 5 or x is equal to negative 5. And we remember that y was negative 10 over x, so we have to find the y to go with the x. So y will be equal to negative 10 over 5, negative 2, or y will equal negative 10 over negative 5, which is positive 2. So my two square roots are 5 minus 2i, or negative 5 plus 2i. We're just going to check that they work. Let's look at 5 minus 2i squared. Remember, we want to end up getting 21 minus 20i, and we do. We get 25 minus 10i minus 10i plus 4i squared, which is 25 minus 4 minus 20i, which is 21 minus 20i, as required. Now you can check the other one. It's pretty straightforward because we could take out a common factor in here of negative 5 minus 2i. When we square that, the negative times the negative will give me a positive, and we get to the same point pretty fast. I'm going to do another example now, and I'm going to go a bit faster. Most of you should be able to get on with the textbook practice now, but here's one more. Okay, so find the square roots of 3 plus 4i. We're going to have z is equal to x plus y squared must equal 3 plus 4i. So it's going to be exactly the same quadratic every time. X squared plus 2 xyi minus y squared equals 3 plus 4i. So x squared minus y squared equals 3. 2xy is 4. I'll just change colour. So y is equal to 2 over x. Take this, pop it back in here. X squared minus 2 over x squared equals 3. Now we're going to get a quartic, multiplying through. X to the power of 4 minus 4 equals 3x squared. Rearrange that. X to the power of 4 minus 3x squared minus 4 equals 0. Right, off we go again. It's a disguised quadratic. X squared here. This time two numbers that multiply to negative 4 and add to negative 3. So it's going to be minus 4 here and plus 1 here. Right, x squared minus 4 times x squared plus 1 equals 0. And we also need to remember what y was. So y was 2 over x. So this one, let's get rid of that one first. No real solutions. X squared minus 4 equals 0 gives me x squared equals 4, x equals plus or minus 2. So if x equals 2, y equals 1. If x equals, negative 2, y is equal to negative 1. So the two square roots are two plus I and negative 2 minus I. And I'm going to leave it for you to check that both of those work and that when we square them we get back to 3 plus 4i. Thanks for watching.